In this research paper titled, "When Does Metadata Conditioning Not Work for Language Model Pre-Training?" A study with context-free grammars, a team of researchers from institutions like the University of Tokyo, Riken AIP, the University of California, Berkeley, and Preferred Networks investigate how adding metadata to training data affects the performance of language models. The lead authors include Rei Higuchi, Ryotaro Kawata, Naoki Nishikawa, and others, with contributions from experts in artificial intelligence and machine learning. Language models, or LMs, are powerful tools that learn from vast amounts of text data, allowing them to adapt to a wide variety of tasks. A key factor in their success is their ability to capture latent semantics, which are the hidden meanings, styles, or contexts underlying the text. For example, a piece of text might have an underlying topic, like science or casual conversation, that isn't immediately obvious but influences how the model processes it. One popular technique to help models access these latent semantics is metadata conditioning. This involves prepending additional information, such as URLs, document domains, or writing styles, to the beginning of texts during the pre-training phase. The idea is that this extra cue makes it easier for the model to understand the context without having to analyze the entire text first. Previous studies, like those by Gao and colleagues, have shown that this can improve performance on certain downstream tasks, such as question answering or text generation, by giving the model a head start on interpreting the data. However, these improvements aren't universal. The paper points out that metadata conditioning doesn't always lead to better results across all tasks, and it doesn't consistently reduce the average loss in next token prediction, which is a common measure of how well a model predicts the next word in a sequence. This raises questions about when and why this technique works or fails. To dig deeper, the researchers conducted experiments using artificial, synthetic data instead of real-world texts, which can be messy and hard to analyze. They drew inspiration from earlier work by Alan Zhu and Li, and generated data based on probabilistic context-free grammars, or CFGs. Context-free grammars are formal systems used in computer science to define the structure of languages, like how sentences are built from words and phrases. By using multiple CFG rules, they created controlled datasets where metadata could be clearly defined and manipulated. In their experiments, they found that prepending metadata has both positive and negative effects on model performance. On the positive side, it helps when the model can use the metadata to infer latent semantics effectively. For instance, if the downstream task provides a long enough context, meaning a sufficient amount of surrounding text, the model can combine the metadata with that context to make better predictions. This aligns with the idea that metadata acts as a helpful prompt, enhancing the model's ability to capture underlying patterns. Conversely, the technique can backfire in situations where the context is too short or lacks the necessary information. In these cases, relying on metadata might lead the model to make incorrect assumptions, resulting in poor performance. The researchers demonstrated this through their CFG-based investigations, showing that accurate posterior inference, basically, the model's ability to update its understanding based on evidence, is crucial. If the context doesn't support that inference, metadata conditioning can actually hinder the model's learning. The paper highlights that real-world datasets often include a mix of structured texts, like those from Wikipedia, and unstructured ones, such as social media posts. This diversity is both a strength and a challenge for language models, as it introduces varied latent semantics. By conditioning on metadata, the goal is to make this diversity more manageable, but as the experiments reveal, it only works under specific conditions. For example, in tasks where the prompt already contains enough clues to infer the semantics, adding metadata during pre-training boosts accuracy. But in tasks with ambiguous or incomplete prompts, it might confuse the model, leading to suboptimal outcomes. This nuanced finding helps explain why earlier studies saw inconsistent results. It's not a one-size-fits-all solution. The researchers emphasize that understanding these dynamics is essential for improving language model training. By using synthetic data from CFGs, they avoided the complexities of real-world data, allowing for a clearer examination of how metadata influences the model's internal representations. Their work suggests that future approaches to pre-training should carefully consider the length and quality of context in downstream tasks before incorporating metadata. Overall, This study provides valuable insights into the limitations and benefits of metadata conditioning, paving the way for more targeted strategies in language model development. By focusing on controllable experiments, the authors offer a foundation for the community to build upon, potentially leading to better designed pre-training methods that maximize the use of diverse data sources.